This is an R2-D2 droid from Droid Depot. This is the fully pre-assembled one, not the custom droid, but it is the same as a custom R-unit droid in terms of functionality. I recently acquired it for reasons that I'm going to explain in a moment. And you can see it has the thruster accessory added to it. I'm going to hit the thruster or the accessory button here. And we see it lights up just fine. We're going to come over here now, and I am going to insert the custom personality chip that I have built with these past few personality chip videos. And if we come back over here, and I fire up the accessory again, there's no light. The accessories don't light up. I didn't know that this was a problem until somebody commented on one of my YouTube videos and said, hey, I've made one of these, but the accessory isn't lighting up. What's going on? Well, I spent a bit of time looking into it. Here is a new personality chip. And if we come back over, now it lights up. So this video is going to be about how to make the accessories light up with your custom personality chip. This is the General Plus website. This is where you can download the development helper tools, such as G+ Gadget, which we had to download to create custom personality chips. It has the tool to encode audio files into the special format that the microcontroller in the droid understands, as well as the tool to organize those audio files into groups and combine them into a single file that you can then write to the memory chip on the personality chip. But now we need to download a new program, G+ Eventer. So go ahead, download that, unzip it, run the installer. When that finishes, run the program. And when you do that, you'll see something like this. What is G+ Eventer, or what does it do? It will embed metadata into the encoded audio files that the microcontroller in the droid will pick up as that file is being played. That metadata will tell the droid, give the droid different actions to take, basically, such as, hey, turn on this LED, and hey, make this LED blink. So we'll just jump right into it. The first thing we need to do is add the audio files, the 12,000 hertz sampled 16-bit PCM wave mono files that you had to create for your personality chip. I'm going to bring in the files for groups 11 and 12. Those are the blasters and thrusters sound effects. And I'm also going to bring in the audio file from group 5, which I'll explain why I'm doing that in a minute. And all the other audio clips from the personality chips don't have this metadata in it. It's just these files that have metadata in them. And my goal for this video is to just recreate what the stock personality chips do, and then you can experiment and expand upon what is in this video. All right, here we have our wave files open. I'm going to start with the blaster files, which are 11.1 and 11.2. And if I click on the play button, we get a blaster sound. So there are two types of the metadata that's going to be stored in the audio files is going to be referred to as events in the documentation for G+ Eventer, thus its name. There are two types of events. There are I/O events, which are going to be represented down here with these multicolored buttons. And then there are user events, which it seems that they only take place at a very specific point in the audio file, whereas I/O events can be constantly happening throughout a portion or the whole of the audio file. you'll get the idea in a minute. So I want to start with inserting a couple user events that we need to do. So I'm going to go to the Edit menu up at the top and go down to Insert User Event, which has a hotkey of Control I. And I need to enter in some user event information. So this user event will have an index of 83, and it will have a value of, or a sub-index I should say, of 3. And it should happen at position 0 at the start of the audio file. I'm going to do this again, Control I. This time the index will be 84, everything else will stay the same. And if you want to go back and look at what user events you've added to a file, you can go down to the Edit menu here, go down to User Event List, which has a hotkey of Shift-L, and you can see a list of all the user events that are currently in the file. So why index 83, 84, why sub-index 3? These are numbers that I found in the stock personality chips. This is the values that they use. Other values will do other things. That's for somebody else to explore and test down the road. I just want to get you started with audio clips that will behave the same way as the stock personality chips behave. So those two user events need to be created, which they have been. And now I need to add 2 I/O events. I need to do I/O events 4 and 5. So if I click on one of these numbers down here, in this case 4, because 4 and 5 are the I/O events we need to work with. I clicked on 4. Now if I hold down the Control key and click on 5, I have selected both of them because I want the same I/O event data for both the left and the right accessories. Yes, I/O event 4 is the left accessory, I/O event 5 is the right accessory, just like user event 83 is the left accessory, user event 84 is the right accessory. You might start to see patterns that will help you take guesses as to how you might go about experimenting with these values later on, but we're going to be laser focused on mimicking the stock personality chip functionality. I/O events 4 and 5, I'm going to then, now that those are selected, I come up here and I'm going to select the whole audio clip by going into Edit and then Select All, or you could just do Control A. And then I'm going to come up to the Function menu and I'm going to select Ramp Down, which has a hotkey of D. And I'm going to leave all the values as they are, initial value of 255, which is the max value, and then the final value of 0, which is the smallest value possible. Click OK, and I get this big ramp, thus the name Ramp Down. So what that's doing is it is setting I/O event 4 and I/O event 5 to start at a high level and then end at a low level. Through testing, it is my belief that these I/O events control the brightness of the LEDs. So when these blaster sounds play, the LEDs for the blasters will start out bright, and then as the sound gets towards the end, the brightness will be, it'll fade out, the light will fade out over time. And that's it. That is how a stock blaster sound effect on stock personality chips have their metadata set up. So now I'm going to do 11.2, another blaster clip the same way. I'm just going to go through this a little faster because this video is going to be very, very long regardless. I/O events 4 and 5, do a ramp down, save, time! The blaster clips are done. Okay, now we're going to go into thruster. So let's see. This is a thruster clip. Yes, you don't need to listen to the whole thing. Where do we begin here? Well, we need to enable those LEDs through user events of 83 and 84. We want them to happen at the very beginning. It'd be useless if the LEDs turned on in the halfway through the audio clip, unless that's the effect you want. And we're going to set the sub-index this time not to 3, but to 13. And we're going to do the same thing again for 84. Again, we want it to start at the beginning. Why a subindex of 13 this time? Again, this is what the stock personality chips do. You can explore other values and see what they do if you would like. The next thing we need to do is just like the blasters, we need to select I/O events 4 and 5. Select the whole thing and do a ramp down. I'm going to click save here just so my work that I've got so far is saved. If something crashes, I'm going to be able to come back to at least this point. And then, new for the thrusters only, I need to add 2 more I/O events. I/O events 20 and 21. I want to select the whole audio clip, go up this time to function and level control. And I'm going to set this to a value of, well, it's already there. I'm going to set this to a value of 96 and hit OK. And now you will see, as I click on different events here, you can see this middle section of the window changes to show just the data for that event. And we can see 4 and 5 have ramp downs, and we can now see that 20 and 21 have a line somewhere around, I don't know, 96 in this scale of 0 to 255. Save that file, and that's it. That is a thruster clip with the stock-ish metadata. Now I'm going to go do the other one in a slightly faster pace. 83 and 84, yep, those are both there. Good. 4 and 5, select the whole thing, do a ramp down. 20 and 21, the whole thing is still selected, don't need to do anything else. Level 96. Good. Saved. Done. Okay. Now the last one, the odd one out. Group 5, the Group 5 audio clip. Audio Group 5 on all the personality chips only have one audio file. And when I was first making personality chips, I had listened to all the different groups and tried to classify what the emotion, for lack of a better word, is for each group. And Group 5 was some kind of emergency or alert sound. So I made something that sounded somewhat like an alert. You get the idea. And it turns out the metadata that all the stock personality chips, except for black, have is they set up metadata here to make the LEDs in the head blink while this audio clip is playing. So if you pay close attention to the LEDs in a BB unit, all the LEDs are going to be sort of in sync. They're the volume, as the volume increases and decreases, the LEDs will fade in and out in sync with them. For an R unit, one of the LEDs of the 3 that they have in the R unit heads will do that. The other 2 will do their own thing. So one of those of the 3 LEDs in the R unit head, if you pay attention, when an audio clip from Group 5 is playing, will start just blinking, whereas it normally doesn't blink. With the BB unit, when you get to when it plays an audio clip from Group 5, and there's only one, its LEDs will blink instead of fading in and out with the volume of the sound being played. And the way that's achieved is a user event taking place at position 0, but the index is going to be 80. Sub-index of 4. And I'll give away this much. If you change that sub-index value to 5, it will blink a little faster. If you change it to a 3, it will blink a little bit slower. Nope. Check that. It will you know what? Why don't you just explore and figure it out? Or wait for me to regain my sanity, having been staring at nothing but this for the last 3 or 4 days. And maybe I'll do a second video that covers all the extra values and functions that I have found in my testing. All right, let's make sure 84, yes, good. Okay, and then I'm going to select the whole thing. I'm going to add an IO event 17. But before I do a level control on it, I'm going to change the start and end values of my selection. I'm just going to add 100 here, take a few hundred out there. And what that's going to do is now when I set the level control for this selection, it's going to set the level a little bit after the audio clip starts, and it's going to stop, or it's going to disable or turn it off a little bit before the audio clip ends. And that's going to set it to a level, or a value, I should say, of 9. And you can sort of see that at the ends of the window there. And I'll hit save, and that's it. So what did that do? You'll have to experiment and figure it out, because I'm just copying what they do in the stock personality chips. So that is it. That is all of the audio files that have metadata created. Now I need to re-encode them and put them into a personality chip. This is the G+ Gadget application. It contains the audio batch converter and file merger utilities that we need to create personality chips with. Because we have added metadata to those audio files, how they get converted has changed a little bit, so I want to cover that real quick. Refresher, if you're creating encoded audio files for the personality chips, the algorithm, which is set up at the top left here, needs to be A3400 Pro 5-bit. Now I'm going to come over here and click Add Files, and I'm going to add not the WAV files that we were working with earlier. I'm going to come over here and change this filter to GEAX files, which are what were created through G+ Eventer. There they are. And I will bring those into the converter. And normally at this point, you would just click Start Encoding and everything would be fine. However, we need to tell G+ and the audio batch converter to pay attention to the audio event, or the IO event data that's in there. And the way we do that is you click on this IO event tab, and it has a bunch of what it's calling here pin indexes, which correspond to the 112 different types of IO events you could set in G+ Eventer. I don't know why the terminology changes between the two applications, but we'll just go with it. So all you have to do here, it's very simple, is you're going to check off the pins, what they're calling pins here, but what we called IO events in G+ Eventer. We need to check those off so it knows to use the data in those IO events. So it's just a matter of 1, 2, 3, 4, 5. Check those off. And then 17, 18, 19, 20, and 21. Now, we didn't use 18 and 19 or 2 and 3 in the example that I was showing you earlier, but you might be able to take some guesses as to how those might be used. So it's worth checking them off here now so that this the audio batch converter will remember what you've checked. So that way the next time you open this up, those will already be checked for you. And that's it. Now it's start encoding. And the output directory is set right there, and you can check that or click that box with the 3 dots to change it if you need to. And that's it. The audio files have been converted. They're now in that directory. Now the next step is to just add them to the personality chip. So back in G+ Gadget, we need to go into the file merger utility. And I am going to open up the project that I had created when I first made this personality chip. And we can see all the files over here organized as I had done originally, except now we're going to be replacing the clip in group 5, the clips in group 12, the clips in group 11. So I'm just going to delete those here now. Over here, remember it's in that SP5 directory I created. Why did I call it SP5? Because all the file names end in SP5. I'm going to sort this by date to make my job a little bit easier so we can see all the files that I just created with G+ Eventer. And I'm going to just bring them all in over to the right hand side. And now I can distribute them accordingly. So the 2 group 11 tracks can go into group 11. And the group 5 track can go all the way up to group 5. And it doesn't really matter if I order the thruster or blaster audio clips. They're all going to get used, but just for the sake of the file naming convention I used, I will order them as 1 and 2 and 1 and 2. The output, where this file, this bin file that we're going to create in a second here to then put on the memory chip that goes in the personality chip, that's specified here. And we can actually change that maybe to, we'll call it V2, because, or maybe we'll call it with flashing action. And the set, this doesn't do anything important. No, we can ignore that. And I just click the merge button. And the file is created. So now all that's left is to burn this thing to a memory chip and see what happens. Now it's time to reprogram my personality chip. I'll be using this. This is the CH341A EEPROM programmer. Here is my memory chip. And I'm going to program it using this thing, which is a little adapter I made to convert a personality chip to something you can plug into this. And it works just like that. Now, I will eventually be sharing this PCB where you can order yourself one from Oshpark or Oshpark. The problem is this is a mistake. The pins are too close together, thus I need this adapter. The pins should just be farther apart. I screwed that up. I have redesigned it and ordered a new batch, but they are not here yet, so I'm just going to have to go with this weird sort of Sega Genesis 32X stack-like thing here. But it works, so I'm going to plug that in, and we can start programming. So here we are in the CH341A programmer. The device is connected, as noted down in the bottom right. So the first thing I'm going to do is I'm going to check this detect button. And it has identified the memory chip that is in the personality chip. So I know it's hooked up, I know it's connected, and I am ready to start programming. So I'm going to open up the file that I created, buzz with flashing action. There it is. I'm going to hit the erase button first, so that way there's nothing on there. And I'm going to hit program, and I'm going to warn you now, it's not going to work because I think the little adapter I just showed you, the distance, the traces between the personality chip and the programmer might be too much. So it might be causing some weird issues. I find that if I try programming it once, it will say it completed, but it didn't really complete. And I'll be able to verify that by clicking the verify button. And okay, so it worked, and it made a complete liar out of me. But if something like this happens for you too, I find do the program twice in a row, and the second time it usually takes. But I didn't have to jump through any hoops. Apparently, the electronic gods are with me at the moment. So that's it. The personality chip is programmed. Now I just got to put it in R2-D2 and see what happens. Okay, R2 is on. I just need to install the newly programmed personality chip. And then we'll come around to the side here and keep an eye on the blaster, or the thruster. And here we go. Just like I expected it. Alright, now let's just bring this guy over here like so, and make sure this other one works. Don't focus on the soldering station. Yep, good. Now I get to show you something a little interesting. So we come to a point you may have anticipated. I have the thruster accessory to test. I don't have a blaster accessory to test. So how am I going to test to make sure that the changes I made for the blasters work? Well, that's where these things come into play. The accessory port, all right, has 3 holes in it on each shoulder of the R unit droids. And if you're looking at it, the pin out here is on the right-hand side is what I'm going to call the LED pin or the LED pin. The middle pin goes to ground, and the right pin goes to a detection pin. The way accessories work, the way the droid knows which accessory has been installed is it sends out some power on this detection pin, and that's going to come back through the ground pin. And how much comes back is going to depend on what resistor is installed here. And different accessories have different resistors in them. And that is how it tells what accessory has been installed. And then the LEDing the accessory, the power, the anode side of the LED gets connected to the LED pin and then goes through to ground. And that when electricity is sent out over the LED pin, this will come on and do whatever it's supposed to do. So what resistor value equals what accessory? There is your answer. 4.7 kilo ohms equals thrusters, 10 kilo ohms equal blasters, and you're saying to yourself, I bet you there's hidden accessories in there with different other resistance values. There aren't. People have looked, have tried everything from 0 ohms to at least 100,000 ohms. Somebody might have gone up to a mega ohm. There's nothing there. So back to the devices that I created. This was just made out of a couple of pieces of junk prototype board here. And I hooked it up in this fashion, which is I have connected to the detector pin 2 resistors, and then I have a switch that lets me select between the 2 resistors, and that will carry that switch carries that through to ground, so I can select 4.7 or 10 kilo ohm resistors. Those are the 2 resistors right there. And then the LED just plugs into that side. Which opens up, by the way, the possibilities of making custom accessories. Totally doable. If you start thinking about doing something like that, one thing to note, the LED pin on the inside, on the internals, the electronic internals of the droid, already has a 100 ohm resistor in line with the LED to limit current through the LED. If you want a slightly dimmer LED, or if you are using something with a lower forward voltage, an LED with a lower forward voltage, like a red LED, you probably want to throw in an extra 100 ohm or maybe 220 ohm resistor in there, just to reduce how much power is going through the LED. So anyways, the plan now is... Excuse me, I'm making a video. The droid just went to sleep. So I'm going to plug these... Well, first I'm going to wake R2-D2 back up and throw these on, and then we can test the blasters. Alright, so here is one of those accessory ports. And I'm just going to plug this in, and we can see how the LED, right, is on the pin here. Remember, the right-hand side, as you're facing this, is where the LED is, so you can get an idea of what I was talking about earlier. I'm going to plug that in like so. Now, interesting thing, you don't need accessories installed on both legs for the accessories to be recognized. I only actually need one here, so I'm going to make sure this guy is turned on again. There we go. And I'm going to press the accessory button. Well, actually, let's take a guess at what accessory I'm going to hear. We can see the switch is going through the top resistor. That is a 4.7K resistor. And what did I say 4.7K was? Thrusters. So we should hear thrusters, will we? Let's find out. Yeah, I actually know what I'm talking about. I'm just as shocked as you are. Okay, and then if we switch it down to the other one, we should now hear blasters. And you can see how the LED is blinking instead of reacting possibly to the noise in the sound clip, like I talked about earlier when we were creating the metadata for the audio files. If we turn it back to the thrusters. So my question to you is, do you think that LED is blinking in sync with the volume of the sound clip, or is that just some kind of random flickering happening? And if you figure out the answer to that, then you'll know what sub-index, what did we set it to on that one? Was it 13? Then you'll know what sub-index 13 is supposed to do. Oh, and one more thing. Might as well do it while we're here. A question that I've had a few times already. What happens if you have a different accessory in each side? So we can see 470 is switched up, 10K is switched down. We'll switch, yep, that's up at the 4.7K, which we know are thrusters. This one over here, the switch is now down to 10K, which is going to be the blasters. And we've already seen that one in action. Why don't you enjoy having a green LED blast you right in the eyeballs? Here we go. Blaster. Thruster. Blaster. Thruster. So they alternate. So if you have a blaster in one and a thruster in the other leg, then you're going to get a blaster sound one time and then a thruster sound the next time, and they'll just keep alternating. That's kind of interesting. So maybe, again, more options. If you build custom accessories and have a custom personality chip to go with your custom accessory, this opens up, more potential, more possibilities here of what you could do. You stuck with me this long, I'll let you peek into my notebook. This is my current working theory on what events do what. So for user events, which can have an index of 80 through 84, the sub-index value and the action that value creates. So if it's a sub-index value of 0, the LED is off. 1 through 8 puts it in a blinking mode. Different values change the duty cycle, meaning how long that LED stays on versus how long it stays off. So if you want it to just have a very short time between when it's on, then it would be like, I think closer to values like 7 or 6. If you want it to just blink very fast and then have a long gap where it's off, you'd want something like 1 or 2. If it's 8, the duty cycle is full, so it stays on the whole time. It's solid color. 9 through 13, it seems to be that flickering pattern that's seen with the thrusters. I don't know if it's random or if it's in sync with the audio. I'm leaning towards that it's random. And then if you have a sub-index value of 14 or 15, the LED will be in sync with the audio. What is the difference between those two? Haven't determined that yet. For I/O events 1 through 5, those control the LED brightness. And for I/O events 17 through 21, all I can figure out is that if it's a blinking mode LED, it controls the blinks what I'm calling the blinks per minute, or the blink rate. So if you set this value to 1, then it's only going to blink once a minute, or once a second. And you can set this to some insane value like 200, and it'll try to blink 200 times a second. If you're in a mode, and I'm calling this sub-index value here, I'm calling this mode, if it's a value other than something that blinks, I'm not sure what it does. The stock personality chips are using this value when it's doing one of the flickering effects, so maybe this controls the flickering effect. I don't know. It's testing this stuff, getting this far, has taken literally days, and there's still more testing to be had. So here's part 2. So user event index has a value of 80 plus a variable that I'm going to call n. IO event, we'll call this set 1 of IO events, can have an IO event will be a value of 1 plus whatever the value of n is, and 17 plus the value of n. What do I mean by that? Well, whenever n is in these formulas up here, if n, for example, has a value of 0, that means user event index 80, or IO event 1, or IO event 17, because n is 0 in these cases. You will be controlling, for BB units, all the LEDs in their head. For an R unit, you'll be controlling the left LED. If n is a value of 1, it's the middle, or if it's 2, it's the right LED in R unit droids. BB units don't. This does nothing for BB units. Then 3 and 4 would be the left and right accessory. So if you want to control the left accessory's brightness, it's IO event set 1, right? Which is 1 plus whatever n is, which is in this case 3. So it would be IO event 4 or IO event 5 would control the brightness for the accessories, the left and right accessories. Or if you want to make them blink, 3 plus 17, so IO event 20. Or if it's 4, IO event 21, those would control, if it's a blinking thing, it would control the blink rate of those accessories. And you don't have to insert those user events at just the beginning. They can be anywhere in the audio clip. So you could have an LED blinking in one go, and then you could have it do something else or turn off at another point in the audio clip to sync it up with whatever the audio clip is doing. So that's my theory up to right now. That is based on a bunch of testing that I've been doing. If you figure more out, absolutely please share it. Share with the classroom. But that's it. That is about it. This very long video about how to make LEDs in a droid blink is over.